In this video, we'll explore the idea of average rate of change. Suppose the child is playing with two toy cars. The blue car is spring-loaded, so it accelerates, as shown in this animation. The red car is battery-powered, so it travels at a constant speed when placed on the floor, as shown in this animation. Let's set up the cars to start at the same time. Suppose that the blue toy car begins moving from rest. The distance d in inches of the car from its starting position, t seconds since the car started moving, is given by the formula d equals 2.8 t squared. Suppose the child turns on the red car and places it down on the floor the moment the blue car started moving, at t equals 0 seconds. Let's see what happens. The blue car passed the red car 5 seconds after the start. Now let's set up the cars back at the start of the race again. Here's the animation again, with blue and red line segments illustrating the distance, in inches, the blue and red cars have traveled from their starting positions. As you watch the animation, consider how you might determine the average speed of the blue car over the first 5 seconds after it started moving. To think about how to determine the average speed of the blue car over the first 5 seconds since it started moving, let's construct a graph of the relationship between the blue car's distance from its starting position and the number of seconds elapsed since it started moving. We've oriented the car to move vertically to more easily see how this graph is constructed. Now let's just look at the red car. We'll now construct a graph of the relationship between the red car's distance from its starting position and the number of seconds elapsed since it started moving. Again, we've oriented this car vertically to more easily see how this graph is constructed. Let's look at both cars together. We'll watch them race again. Notice that the graphs intersect at the point 5, 70. This means that the red car's distance from its starting position is the same as the blue car's distance from its starting position 5 seconds after each car started moving. We can see from the graph that both the red and blue cars traveled 70 inches over the first 5 seconds since they started moving. But the red car traveled at a constant speed, whereas the blue car was accelerating. Specifically, the red car traveled at a constant speed of 70 divided by 5, or 14 inches per second. Since the blue car traveled the same distance as the red car over the first 5 seconds since they started moving, the blue car's average speed over this interval of time is equal to the constant speed of the red car, which is 14 inches per second. And this is the meaning of average speed. The average speed of the car over the interval from 0 to 5 seconds is the constant speed required for another object to travel the same distance in the same amount of time. So in our situation, the constant speed of the red car is the average speed of the blue car over the interval of time from t equals 0 seconds to t equals 5 seconds. The meaning of average when talking about average speed is not the same as the average of a set of numbers. It's important to remember that when calculating an average speed, you do not add up a set of numbers and divide by how many numbers you've added. Suppose that this graph represents the distance an object has traveled away from some initial position in relation to the amount of time elapsed since the object began traveling away. We know that the object's average speed over the interval of time from t1 to t2 is the constant speed that a second object would have to travel to cover the same distance as the first in this interval of time from t1 to t2. We calculate this constant speed by dividing the object's change in distance by the corresponding change in time. So the average speed of the first object is given by the ratio f of t2 minus f of t1 divided by t2 minus t1.